Hello, should be live. How's it going, everyone? If you're already joining it in, say hello in the chat. Be keeping an eye on it. And we're a minute early, so we want to wait for, or a couple of minutes early. So we're going to wait for people to join in. But again, as you're joining, it's always fun for me, and I think everyone else, if you say hello in the chat. And feel free to ask questions there as we go, and I'll try to bring those into the conversation. If I don't get to it, sometimes the chat gets pretty busy, and sometimes I want to get through like a chunk of the code or presentation. So if I don't get to it right away and I do miss it, feel free to ask it again. But I try to do a good job of getting to kind of all the comments or questions in the chat. And again, a couple of minutes early. So we'll wait for people to start showing up. But if you also want to let us know what you're working on, if you're doing stuff in the machine learning AI space, which I feel like if you're here, it's very likely that you are, whether you're learning or professionally doing anything like that currently. Let me know in the chat too, like what you're working on. It's always kind of interesting. And I'm going to share this several times, especially as more people start joining in. But here is the code link. So I'm going to go through just a few slides. It's not that much, really, just to set up the concepts of what we're going to be doing today. And then we'll go through the code. And I'll run everything with you and walk through the code. But if you want to get started running through it yourself, you're more than welcome to. I see some people joining. And let me also just double check the event that I posted in. Make sure like the blast went out saying we're live. Just make sure the link is working there as well. Cool. Looks like it is. I see a couple people. Again, I guess it's right on time. So people will probably be showing up more. Again, as you're joining, seeing chunks of people come in, say hello in the chat. We'll get going here shortly. But I do want to give a couple minutes for people to start coming in. And since I saw another chunk of people, if you want to start looking at the code, you can do this so here on GitHub. I think all the links should also be in the description of the video. So also if you're coming back and watching the recording of this, you should be able to click down and find everything as well. Somebody said hello, and someone else said hello from New York City. Awesome. I was in New York in, I think it was February. It's always really fun. I love visiting. I'm in Seattle. So almost opposite end of the country. Anyone, I think we'll wait another minute for people to show up. Also, if you want to share, it's really fun to see where people are streaming in from. If you also want to share a little bit about what you're working on, that's great as well. There's also a Slack group, not required or anything for this workshop, but if you do want to join it and say hello in there as well, quite a few practitioners in there. I'm in there, and there's like a more permanent introduction channel as well. And we host other events around AI and machine learning. I do an AI book club. That's kind of all posted in there as well. All right, I'm going to wait one more minute, and then we'll start going through the slides. Like I mentioned, there's not that many slides here. It's really just to set up the conversations, add a little bit of buffer time again for people to join in, and then I will walk through the code. But if you do want to walk through the code, again, you can go to the GitHub. There's a open and collab button. That's going to be the easiest way for you to run it if you actually want to follow along during the workshop. You're also welcome to just watch. I think it's more fun if you follow along, but totally up to you. And I'll just quickly actually show what we're going to build before I go into the slides here. So we're going to build a pipeline that's going to train a BERT model. We'll talk more about BERT models if you haven't used them before. It's a certain type of, well, some people say LM, some people say it's not quite an LM. I think there's no definition for how large a model has to be, but it's a language transformer. It's one of the earlier ones. I think in 2018 or 2019 is when it came out. And it's really popular actually still as a model in production that's like in a data set with pipelines, or sorry, in a pipeline with data, like operating on your data. It's still, I think, when I talk to people and when you look at like the Hugging Face download numbers, it's actually still one of the most popular open source language models. And we'll talk about why. But we're going to build a pipeline that is going to fine tune it on a data set. So we're going to pull in the data set that's on Hugging Face. You'll be able to swap this out with your own data. So if you run through this and like what you see, and you actually have ideas of how to put this in production, swap out your own data. You can swap out with a different type of BERT model if you want as well. And then here you can see we have this training report. So this is our training loss going down, and then our accuracy going up here at the end over time on the data set. And the data set that we're going to train on has like six different emotions that we're going to do classification for. And so BERT model, again, go into this a little bit later, but the BERT model works really good as a language model that is an encoder-based language model. So it's not going to be generating code like a GPT model. It's going to be taking in unstructured data like text coming in a pipeline, and then in our case, performing some sort of emotion that you're going to assign to it. And this is like a use case that's actually used a lot in production, where you would run a BERT model. Twitter might not do this anymore, or X, but originally they were using a BERT model for every single tweet, basically, and running some sort of classification on it. If it's for like sentiment or harassment or anything like that, we'll basically see what that looks like in our pipeline today. But you can also use it for like when I talk to companies like in healthcare or insurance, it's a pretty common model to have in production where you're looking at unstructured data and then doing something like a classification or named entity recognition with it. And then it's very cheap to run because it's only like 100 and something million parameters versus billions. And you get really, really good classification results that are more reliable than using like an autoregressive model. Then we're going to evaluate the model. So we'll get a report here. So these are HTML reports that we generate in our pipeline that we'll look at in the code. And then this is the evaluation for this one I just ran. You can see that I compare here like the base model. Zoom in if you can't see this. So the base model, which it wasn't fine-tuned specifically for the emotion analysis. You can see it's not doing incredibly well, especially on some of these ones like love and sadness. And you can see that then this is our fine-tuned model, this darker bar, and it's actually doing really, really good results. Just also in this case, like for a few epochs and a sample of the data set. So we want to make this so you can actually run it during the workshop time. But you're welcome to take the code and then run it for much longer and get even better results potentially. And we have a confusion matrix so we can see how well our model is doing on each of these classes. And it, if it's mispredicting, where is it mispredicting? Like we can see that this love one is mispredicted with joy, which makes sense probably because they're probably pretty closely related. And then we'll see, you can see like the base model versus fine-tuned one. And then finally, we'll also have this kind of a report where I'm calling it like explore inference. So you can run inference on some other data coming in. And then we'll look at how it predicts it. In this case, like you can see that this is the text that said, I was feeling really troubled and down over what my dad said. And it's predicting this as sadness 100%. It doesn't think it's any of the other ones. And then we actually look at the attention layer coming out of the BERT model. We'll actually apply some kind of like a heat map on the words to be like, what are the words that are really triggering this? Obviously, troubled. You can also see, they were really troubled, feeling troubled. My dad, you can see what it's kind of paying attention to. And then it kind of ranks the token importance for why it ranked it as sadness. So let me see if there's one that's a little bit more, not 100% sure. I guess these ones are mostly very confident, but it is a kind of a cool way to troubleshoot why your model might be giving you those results. And then finally, once we have this trained model, we'll actually go deploy it in a Gradio app here that's also running in the Flyte, which I'll talk about. But here we can run this. And you can see how fast this is. So this is, again, just a BERT model. It's running on a T4 here. It could run on a lesser class GPU because it's so small. You could actually probably even run this on a CPU if you're okay with a lot more latency here. And we don't even have this really configured to be incredibly fast here with like flash attention or any other optimizations. And you can see how fast this BERT model is running our classification for text coming in. So again, you could think of the use case today if you're doing some sort of auto monitoring on a chat or like chat rooms and games or social media, etc. And this is like where it's a very common use case. And then, like I mentioned, in production as classification where there's any other unstructured text. So like when I talk to non-traditional tech companies too, like insurance, healthcare, etc., BERT model really is one of the most common ones that's in production in a pipeline on their own data. So I see a whole bunch of more people joined in. I'm going to share the link again to the code. I was just kind of giving a preview of what we're going to build. And so there's the code. If you want to start poking around, there's a open and collab link. So if you actually want to go ahead and even just run the stuff in collab or poke around in the code, you are more than welcome to. I'm going to get there pretty shortly. I'm going to go through a few slides and then we'll be good to go. Is everyone good with that? I see a lot of people here and it should be pretty fun. And I'll share the Slack group link one more time as well if people want to stay connected in there. I see someone else joined in from LA. Welcome. All right. So just a tiny bit about me and then call to action again for people joining in, because I see a lot more now too, is tell us about you. So again, say hello in the chat, mention what you're working on, where you're streaming from. It's always really fun to hear. I think it's more fun for people in the audience to hear as well. So my name is Sage Elliott. I work at Union AI, and we have a really popular open source called Flyte, which we're going to use today as well. And I'll talk a little bit about the differences there. I live in Seattle. A lot of people know me right now from running an AI book club that I run online as well, where we read a new book every month and then discuss it online. That's been really, really fun. So if you want more information on that, you can join the Slack channel, go to the AI Reading Club channel there. Previously, I've done a lot of work in computer vision, ML monitoring, evaluation, ML ops, and then even before more of the software world, I had a previous kind of career more in hardware and like IoT and a little bit of robotics. And I still really like bringing those things together sometimes as well. I'm actually really excited to probably do more in the physical AI simulation space this summer. So if you're interested in like world models and that type of stuff too, follow me or just stay connected for any other reason. If you want to be friends, you can connect me on LinkedIn. But if you want to see kind of that type of content in the future, you can follow me there. And then again, like I was saying, a lot of this discussion and posting for the events and stuff like that also happen in the Slack group. So you should also intro yourself there and give a little bit more of a permanent introduction. You probably already know this, LLM fine-tuning. Why do you need it? Most LLMs are trained on general data, not your specific domain or task. And it's a little bit different. So I just copied the slide over from, I did like a fine-tuning workshop with Laura and QLaura. BERT model, which we're going to use today, is actually pretty small, like very small, where we don't need to use Laura QLaura. It's basically overkill for this type of model. But you want to fine-tune a model for your specific task. So if you were just here a minute ago, right, like we were going to train our model today to take in unstructured data, like sentences or paragraphs, and then it'll be able to classify not a sentiment, emotion today. But it's also very common for like sentiment analysis. A lot of times you'll actually see like this type of tutorial used. There's another data set that's like a movie review data set, and basically just get binary classification of was that a positive or negative review. But we're going to go a little bit beyond that and do 6 emotions today, which I think a little bit more fun than the binary classification. BERT models. So bidirectional encoder representation from transformers is what BERT stands for. BERT reads words in both directions at once, so it understands context really well. So it's more on the encoder side. Again, if you've been using like the generative models, that's usually a decoder doing the generation, where it's looking at the past words and then generating the next token. The encoder side actually looks at like the entire unstructured data coming in, and then you can train it to do something with that kind of embedding space. And then if you look at that or have it look at it and generate something like a classification, which I think is the most common use case for this. But you can also do like named entity recognition, some question answering, but not like the generative type where you get like a whole tokens afterwards, and then sentiment, like we're going to kind of do that today with classification. And it's really, really fast for production, and it's still a really strong, cost-effective baseline. So even with today's like giant generative models, if you're putting stuff in production, you want more control over it, and you also don't want to pay for a massive amount of potential tokens coming in all the time. It's going to be a really good model to use. And like I was saying, it's still, when I talk to a lot of companies with certain types of stuff in production, it's very, very common. And if you go to also the Hugging Face blog on Modern BERT, it does a really good job of breaking this down a little bit more. And actually, I think I had a page I even wanted to pull up. Actually, it might be linked in here. So they talk about how it's one of the most downloaded models, or it was, I think, the most downloaded model when they wrote that blog 2 years ago. And you can still see that BERT is still the #3 model for downloads in the Hugging Face Hub. So it's still very widely used. I think these other ones are basically encoding models too. So probably some similar use cases there, but very widely used open source model. And modern BERT is what we're going to use today, which that blog type tells us a little bit more about. I'm not going to go too deep into that specific type or anything like that, but it's a BERT-based model, the bidirectional encoder model, but with some cool learnings from LMs really taking off. And the first BERT model, actually, since I have the archive link, I would say I think it's 2018. Okay, 2018. I guess revised 2019. This was one of the first transformer models that I feel like really brought to light like all the really cool stuff you could do with it. And I knew people working with this back before like GPT kind of blew up and LMs took over the AI space. So really, really cool model. And we're going to use this today for our classification on unstructured data. And then Hugging Face transformers, we're going to use this as our library to pull in the model and then also do training. Has anyone used Hugging Face before? Or actually, has anyone done a BERT model before? That's a good question too. Has anyone done BERT models or used Hugging Face? If you've been working with any open source LMs or transformers, chances are very, very high that you've worked with Hugging Face before. They give you a hub of all those like cool transformer models like we just saw at the list. Everyone publishes their open source ones there. And then you also get a really nice API for doing things like not only pulling those in, but also doing things like setting up the training arguments and then actually training the model. So you have to write very, very little code to actually do training. And so this is actually taken from a code snippet from our training today. We're just set parameters and then we'll be able to train our BERT model. And then we're going to use Flyte or Union. So I just want to be clear that everything we're going to do today, you can actually do on the open source. And in the notebook, there is like a step that says if you do want to run this on the open source, like Flyte DevBox, you can do so. The only reason why I'm using Union for you to follow along today is that one, it's going to be easier because you don't have to do really any setup for it. You'll be able to kick it off from a collab. And then two, I don't expect everybody to have a GPU. And since we're actually fine-tuning a model, even though it's pretty small, you need to have some sort of accelerator or GPU today. So I made a tenant where we have a kind of a demo tenant that I can onboard people to. And if you RSVP'd on Luma before 11 a.m. Pacific time, you should be onboarded to that tenant. And you should actually be able to access our GPU just for during the workshop. You'll probably be offboarded a little bit after that. But we're going to use Union today, which is like a hosted version of Flyte, and it has some other features as well. But Flyte is an AI orchestration platform, and it gives you the power to define like your containers that you want your tasks to run in. And our pipeline today is a collection of tasks, right? It's going to be downloading the data set, training a model, etc. You're going to do that really efficiently just in a Python SDK here. So you can say like, we're going to have a GPU task and a CPU task, because for downloading data set, we don't want to be hogging our GPU. That's very expensive, or other people could be using that. So we're going to switch between the CPU task where we define in our SDK here the image that we want it to run in, and then how much memory we want, how many GPUs we want. And then we have this other CPU lighter weight container or environment basically that is going to run with just 2 CPUs and then 4 gigabytes of memory. And that was the UI you saw earlier, which you'll see again. You also get this UI. You can run in your cloud or on-premise, not a serverless project. That's why you can't just sign up. I had to onboard you into like a demo tenant that I have. It's declarative infrastructure, just like you see here. So this code snippet just tells you like how to write your environments. Like, I don't know if you've written Docker files before, but instead of writing Docker files, you can actually just define how you want your container to look directly in your Python SDK right here. So you never have to leave a project. In this case, we're just going to be reading in from a requirements.txt. But you can also put in more stuff like apt-get or install specific packages. What type of CUDA do you need for your environment? You just declare it all here very, very easily. You can also define secrets. We don't need any today, but if you had to put in your Hugging Face token because you want to use a gated model instead of the modern BERT, you can add that here really easily as well. And then once you get these environments defined, we're going to add a decorator above Python functions like you normally write. So it's just all written in pure Python. But then you get all these kind of really cool things on top of it. So in that UI, we saw that it had like all those tasks, but you get versions. So every time you run the pipeline, it's all versioned. You can come back, you can do hyperparameter tuning, compare them, etc. You get caching. So like we cache the data set download. So when we rerun the entire workflow, it doesn't have to download the data set again. Very flexible plugin ecosystem, but it's also pure Python. So you can usually do kind of anything you want, even without an official plugin. And then it's built on top of Kubernetes. So if you want kind of that scalability, reproducibility piece, that's all there for you. Very easy to use just from the Python SDK. So again, we'll go through this code. Is everyone ready to train a model and deploy it? Or at least watch me do it, or look at the code if you don't actually want to follow along. And again, so this is like the UI we're going to get. You get a version of every run, like I mentioned here. These reports are embedded. So this is the Union version of the UI, but Flyte looks very similar. It just is like purple and white instead. And like I mentioned, we're using Union, so it's hosted with a GPU for you today. But everything we're going to do today, you can do in the open source as well. All right, so I shared a link. Let me know if you have any questions real quick. I'm going to pause just for any questions. Is everyone able to open up the link? Let me, but I'm going to actually follow along on my personal email so I can really replicate. Let me see. I should be able to really replicate following along like you will be following along. So I'm going to do this in this other window. I pasted in the link. There's this open in Colab. Again, if you want to follow along, you can click on this. And I might go back and forth between the Colab and my IDE to show off the code. I am trying something new where I'm kind of embedding the code in the Colab too. So let me know if that works or not. I think it'll be good. If not, I will go back to the IDE. You can run this directly from here. I often, if I'm following along on a tutorial, I like to go to File, save a copy and drive. This gives me my own copy of the thing. So I can always go back to this and edit it. Or if I edit any code, I can just come back to that version of it. Otherwise, if you do any edits, you won't be able to save it. But you can always come back to this link. And so don't worry about breaking anything if you do edit any code. And then here's the direct Colab link. So if you do want to follow along, should be able to click on that link directly and then start running this. And if you haven't used Colab before, it's Google's way of hosting a Jupyter notebook, but it gives you a whole little environment. So it's going to allow us to download like a GitHub repo and then kick off runs, which is what we're going to do today. So I already kind of described what we're building, so I'll probably gloss over some of the top stuff here. You run this first cell. It's going to look to see if it's Colab. If it's true, it's going to do all this stuff here. So it's going to go ahead and download the workshop repo to our instance here. It's going to change directory into the BERT fine-tuning example that we're going to run. It's going to install requirements.txt. And then this is really just something you have to do in Colab or some headless environments if you don't have a keyring installed, is we're installing keyring alts. And what this is going to do is basically just allow us to authenticate once. Otherwise, if you don't install this in like a headless environment without a keyring, it's going to keep asking you to authenticate. It's going to be kind of annoying. But if you're running this locally on like a Mac or Windows, you shouldn't have to do this at all. And then we're setting this environment variable to saying term is equal dumb. I didn't come up with this term. I think the terminal is great, but I have to call it dumb here because if we don't do this, then it's going to format things a little bit weird when it outputs things. It's just like a weird Colab type of thing. So we can see everything got installed here. And then I should be able to go to this next code cell, which is setting up our Flyte configuration. So we're running Flyte create config. And then here we're passing in the endpoint as try-v2 hosted unionai.cloud. This is that demo tenant that I talked about that you should be onboarded to if you RCP'd on Luma. Again, if it was before like 11 a.m. If you did just RCP, you might not be in there. If you message me on Slack or LinkedIn later, I'd be happy to add you if you do want to run this after the live workshop here. And then we pass in a project, workshop BERT. This is the project that we should all have access to. We'll see this in a second. Make sure that you do. Domain development, so you can add in different domains like development, staging, production, etc. As you're kind of transitioning pipelines to where they're going to live. We're just going to leave it in development for now. Builders equal remote. This is going to build the Docker images remotely. So it's going to look at our defined containers that we want to run our pipeline in, our tasks in, and then it's going to say, oh, does this container exist? Yes or no. If it doesn't, I'm going to go ahead and build it remotely and then pull it into the cluster and then run the thing in there. So it makes it really, really easy to work with like Docker images and get that reproducibility. And then authentication, we're just setting to headless. This just gives you a little bit of a different way of doing this because we're in headless Colab environment. If you're running this locally, you wouldn't need this here. And if you do want to run this locally, so again, you have a demo cluster for this workshop right now. But if you do want to run this just locally, you can set up a single node cluster with Flyte DevBox. Like I was mentioning, you can do this all in open source that you're going to see today. So you can click this link here if you want to read more about the DevBox. And then if you're running this locally, you would just run this setup instead of this configuration. And it's going to tell you like the endpoint's going to be a local host endpoint, and then you're going to build the Docker images locally and then store them there. And we don't need to set this up, but if you are using gated models later, you just set this environment variable for your Hugging Face token. All right, so we're going to walk through all the code, but I find usually when I'm running the workshops, it's a little bit better to first just run the pipeline code. That's going to verify that you got the configuration stuff set up. Then you can look at the platform, and then you can go into the code and kind of see what the code is doing to create what we're seeing in the platform. So if you want to run this next code cell, where you can see that we're looking at training for just 3 epochs. So it's going to look at the entire data set that we pass in, this 4,000 examples 3 times, and then it's going to evaluate on 200 examples, and then we'll explore inference on 12 examples here. So it's going to ask you to authenticate for the first time here. Go ahead and click on that link, hit next there. I already have an account here with my email, but if you don't, it should ask you to create an account. The easiest way is just to do that like OAuth with Google, and then you should be good to go. And we can see that it is now running, actually. I think it's because I already ran this before, and it's built the container image for me. That might work for you too, since we're on the same cluster. But if it might, I forget, because you're on a different account, it actually might have to build the image again. So if it does say building image, then you're just going to have to wait a minute for that to be done, and then it'll kick off a run. You can also see, if I click on this link, because the Google Colab terminal just sometimes kind of breaks stuff. If I click on this, you can see that it's just this top part's clickable, this bottom part isn't. If I click on it, it's going to give me like an error that project doesn't exist. So if you go to this URL, you should be able to see all of your projects. If this is your first workshop, you'll just see this workshop BERT one, which I'll share the direct link for that as well. And cool, I see other people running this, building the image. Oh, I guess mine's building the image again. I might have made a change right before running the workshop, so that might be why. Oh no, sorry, it's not doing the image. It's actually running the pipeline. Perfect. Okay, so our image was already built. It was already built for the other people as well because I did run it before the workshop. Now it's actually running the pipeline here. This might take a few minutes to gather the resources. Again, this is on like a lighter weight demo cluster. And the resources are probably all spun down because I didn't rerun this like 30 minutes before the workshop. So it's probably spun down. It might take a minute or a few minutes to gather those resources, provision them, and then start running stuff. But if you actually have more hot resources, this is really, really fast to run here. I mean, that's part of just kind of the efficiency of using Kubernetes, where you're not paying for those resources, or you're not consuming those resources until you need to. So I can see that this person started running, and then it should pull in. Because I ran this before, you can actually see that this data set is cached. So it's 0 seconds there because I actually didn't have to download that data set again. It was already there. Really cool thing about caching. Caching is also really fun for debugging things. Like if you just want to get to the end part of a workflow, including for agents. So if you're like want to iterate on a later agent or sub agent and you don't want to run all the stuff previously, you can just enable caching at least for the debugging phase, and then it'll just you can run that next iteration of the pipeline there. So while this is running, I saw it at least worked for one person. I don't know if other people are still setting up, or did anyone run into any issues? I guess I'll pause there just to make sure before I keep going to the code. And it might take the whole pipeline might take something like 15 minutes to run or something like that. So it's perfect for me to walk through the code while it's kind of running. No questions. Everyone's having a good time. People who want to follow along are following along. Since there's no questions, I assume it's good, but let me know if you have any problems or any questions. I'll be watching the chat. I'm going to quickly note too. So we run this, we say Flyte run workflow.py. And we downloaded all this code when we did that GitHub run. So actually, if you click in to this folder icon on Colab, you can see this workshops folder, tutorials, and then ours is this BERT fine tuning emotion one. So you can click into here. And this is like the entire full workflow.py code file that I'm going to show you. So you can click in, you can actually edit and save this in here. And then do like run it again if you did variations. But what I did is usually during a workshop, I'll have to just show it directly from my IDE. But I'm trying something new again. So let me know if this is a good idea or not. I have this little view file helper I made, and then I load the Python code directly into the notebook. So you should be able to scroll down and see all this code. So I'm going to try showing it from there, but let me know if it doesn't work for some reason for you. So that workflow.py contains that workflow. We'll look at the code here in a second. There's a pipeline function or a Flyte task. And in V2, which is what we're using for Flyte, everything's a task now. There used to be a workflow decorator for V1. So you would create tasks like the get data, train a model. Then you would put them into a workflow decorator, and you'd get a static DAG that was compiled out of that. Now you just create another task and call other tasks from it. And tasks, even workflow tasks, can be fully dynamic now. So it's all pure Python. You can use like loops. You can use if statements directly in there, whereas V1, you couldn't do that. So now you can write agents and really dynamic workflows depending on like the inputs coming into it. Then we're passing in some parameters. We're just saying we want FX3. We want to look at 4,000 samples from that data set. I think the data set's something like 20K samples. So if we wanted to get better results, we probably want to pass in more data, but it would take a lot more time to train. The number that we're going to evaluate on after our model trains is 200. And then we're going to explore 12 examples in that kind of inference piece and see where the attention is on the tokens coming in. If you want to run this locally, by the way, you can also just add in this local flag. And we also have a terminal user interface that shows up in the terminal, the TUI, which is really nice. So it's really good to be able to iterate locally. Like if you're just going to do one epic or something like that, but you want to make sure that the pipeline actually runs. Like if you have an accelerator or you want to run on your Mac GPU, you can test this here, do very quick iterations locally before kicking off a remote run, which might take a little bit more time, like has to build the image. If you're doing like a lot of debugging in that area, and then it also has to spin up the resources, etc. So Flyte makes it really easy to do local iteration and development, and then connect to your cloud when you want to. So let's do code walkthrough. First, we have this config.py, and this is where I define those environments. If you were here at the beginning of the slides, talked about setting up two environments, one with a CPU, one with a GPU for training and inference, and then the CPU task. We don't want to be hogging a GPU when we're just like downloading data set, for example. So we do that here. Oh, and this should be commented out. I think because I ran this previously, if I rerun this, it'll actually import the current version. I don't think the other one's changed. I commented this out because we're not actually using it. Otherwise, it's going to look for a Hugging Face token. But this is, again, how we define our containers. So we're reading from that requirements.txt. We're creating a base image from Debian, and then you could add in other things through apt-get or other ways to install packages here. And this is going to build our Docker container that our tasks are going to run in. And we just have the same base image here for both of our environments, but you could have multiple ones. And then the difference between our two here is the resources that we just defined, again, directly in Python. We want 4 CPUs, we want 16 gigabytes of memory, and then we want one T4, which I know is available in our cluster here, but you could have different types of GPUs. So if you have a bigger cloud Kubernetes cluster on AWS or Azure, for example, you could define like A100s and you want 2 of them or whatever. Again, just right here in your code. So really easy for you as like the AI engineer to work with those resources. And then for our CPU one, we just want 2 CPUs, 4 gigabytes memory. This is good enough just to download and save our data set. And then our requirements.txt, these are the libraries we're using: Flyte, PyTorch, Transformers, datasets, which is another Hugging Face library, Accelerate, which is another Hugging Face library to help acceleration on Transformers. Scikit-learn, I think I just use this actually to pull in the confusion matrix and some of the classification report stuff. NumPy, python.env to read environment variables. And when we serve our model, we're going to be using FastAPI, HTTPX, and Gradio and Pydantic. And then now here is our workflow.py. So we're going to be looking at the code for building this workflow that's running. Cool. I see other people running the code now. Awesome. So this workflow, again, we have get data, train, evaluate, and explore inference. So this is going to be the code for that, for training our modern BERT. So again, let me try this in the Colab, but I might switch to the IDE if it just doesn't look very good in here. We have our imports, a couple of things setting logging. These are our emotion labels. So we have sadness, joy, love, anger, fear, and surprise. That's inside that data set. And this is the data set. It's also linked in the README, by the way, too. So if we want to go dig in that data set, you can. And then you could swap out this data set. You could swap out this to a different BERT model or other models as well, but is designed for BERT models. And then the only thing is, if you're swapping out a data set, keep in mind that it would have different emotion different base labels coming out, and it might have a different number. So this is 6. You'd have to make sure you're just doing classification for the amount that you're doing, and then you'd put in those labels here. And then we define our first task, which is get data. And I pointed out in the UI when people were running it how it was cached, and we pass in this parameter cache auto to the task. And if this code in here doesn't change, or the parameters coming in don't change, then it's going to cache it. But for example, if we pass in a different amount of training data, it should see that, and then it will rerun that step because the code is different in there now. Otherwise, it'll skip running it, and then just in our case, it's going to pull in the next task, pull that already downloaded data set. So nothing really crazy here, just downloading data set. I guess another thing to feature is Flyte has this concept of Flyte directories and Flyte file. So if you've never worked with containers before, it's kind of interesting because you spin up a separate like compute environment, basically, right, to do these tasks in, like this get data, for example. But then when you're done using it, it spins down. So if you've just done like local development and you didn't really have to think about containers, you're like, oh, wait, I downloaded a data set. Where did it go? If you didn't save it anywhere, then it's going to just kind of disappear. So Flyte is always also on a blob store of some sort, like S3 or Azure blob storage. And then we have this concept called Flyte file and Flyte directory. So when you output as a Flyte directory, it's going to save that just automatically to that blob storage. And then you don't really have to think about it as in like, where do I save this? How do I make this accessible outside of tasks once the container spun down? It just kind of handles that automatically. So that's what we're doing here. And then we have our next task, which is train. And we can see we're reading in this data directory. We can see it's a Flyte IO directory. Flyte also kind of forces you to do strongly typed inputs and outputs. So some people really like this. I think when you get started and you're building a modern pipeline, people kind of really prefer to have that in there. So you can look at this and see exactly what it's expecting. But it'll yell at you if you have, a number coming in instead of a string here, which is kind of nice. Again, quicker debugging and better handoff for different team members. So model name, data directory that we just did, the epics, learning rate, batch size, warm-up steps, those all get passed in as hyperparameters here. Do some imports in this task. You'll also see, I'm going to gloss over a lot of this part, or parts that are just HTML. I tried to separate some of it out into a separate folder. HTML is what gives us these really cool looking reports. So like when we look at this report tab inside of Flyte or Union, in this case, like we have this training one, really nice to see. Same with like the inference, etc. You can do really, really cool stuff in here. I work a lot with reports, and I have like even stuff for reinforcement simulation environments. You can embed frames here and actually see like what did the run look like without having to go and export like a whole video, which is really nice. But if you just see a lot of HTML, which I'm going to gloss over, that's just building those reports here. We download our data set into this task, initialize a tokenizer for our model, and then we set up our model. It's going to be auto model for sequence classification. Again, if you're doing a generation model, if you're going to fine tune a generative model, this is very, very similar to, by the way, like you could take all this and just modify it a little bit. But instead of for sequence classification, it'd be like auto regressive model. And then they have these concepts like auto model and auto tokenizer, where you can pass in the model from Hugging Face, and it usually does a really good job of automatically getting the tokenizer or setting up the model configs for that specific model. Pass in the model name. Again, Hugging Face token is optional. And again, number of labels, in our case is 6, but you would change this if you were doing this on your own data set and you had more or less labels. So just keep that in mind. We log out like total parameters. We see which type of accelerator that we have and get some information on it. We'll then initialize like a training log as empty lists here. And then again, here's some HTML that I'm going to gloss over, but we're basically just printing out some of that data in a report here that we're going to see. And the same for this charts one. I'm going to gloss over this, but this just builds some of those fancy looking charts. I should actually probably just make this function in a separate file so that it's a little bit cleaner in our actual training code here. So I might go update that after this workshop. We have a reports callback. So every time it does the epic, it's going to log that information that we defined above, which again is kind of that fancy chart that we saw. We're computing those metrics that we're going to log there. And then this is the actual, this is the actual training. It looks a little bit different than when I look at it in my IDE, like the way I have the colors and stuff. So it threw me off a little bit. So this is our training setup here. We're saying the output directory that we want to save it in as it's training is this kind of temporary directory by default. We're going to pass in these training args, which is the output directory, number of epics, batch size, basically all those parameters that we set up before. It's going to evaluate on every epic. It's going to save on every epic. And then it's going to load the best model at the end is true. So it's going to basically have that temporary one. It's going to evaluate on epic and then load in what was the best one on that performance metric by default at the end. This is kind of a built-in thing to Hugging Face, but you might have done this on other machine learning models before, where you're basically just saying that, you can kind of overtrain, and then maybe the model wasn't the best at the end, though. It happened somewhere else in there, and you started overfitting, and the evaluation metrics started looking worse. So you want to get the best version of that model. Oh, and the metric for best model is actually the F1 square here. And then this is the actual trainer piece. So again, in Hugging Face, you just import this trainer, and then you pass in the model, those training arguments that we set up before, the train and evaluate parts of the data set, the tokenizer that we initialize, that compute metric that we initialized before, and then the report callback that we initialize. And then it's just going to log that stuff out. And again, this is, again, a lot of the kind of logging and charts that we see in our train task here. So we get these nice charts as you go. Your loss hopefully is continuing going down. In this case, you can see it was probably still going down. So we could probably train for more epics here, also bring in more data than that 4,000 example that we did. Then we have our evaluate task, which we click in here. Gives us this comparison accuracy on the base model versus fine tune. Again, we didn't really train it for very long or on the full data set, so we could probably get even better accuracy, but this is pretty good just on 3 epics, just for this kind of workshop demo, something that you can run in like the 10 minutes for the training. It took 11 minutes or almost 12 minutes for the training here. We're actually already getting pretty good results. And then we do that, the bar chart and the confusion matrix, which tells us, like, this is, you always want these darker lines here in the confusion matrix saying like most of the prediction for that class for joy was predicted as joy. But you can also see that some of them, like for this actual one was joy here. But again, some of them were predicted as love, which again, there's probably some similarity of that positive language. So it makes sense. Would be more probably scary is when you're seeing like, we see one here, but like joy is always being predicted as anger. That's going to tell your models like not doing very good there, and maybe you want to look at adding more variation of your data or something else like more epochs to make it perform better. And then we get that per class metrics. So we can see for each of these what their score is. We see surprise is pretty low. Love's actually pretty low in this case too. So again, maybe getting this classified as a joy, or there isn't as much variation in there. Yeah, we can see for love, it looks like there isn't as many samples, and then a lot of them are for our 200 samples here getting predicted as joy. So the evaluate one, basically we pass in the model that we fine tune. So we have this fine tuned model directory. It's also a Flyte directory, data directory gets passed in. We get the 200 samples that we're going to compare on, and we just load in that model. Again, a lot of this is the HTML here to build that report as well. We load in that model, pass in those 200 examples. We get the inferred classes back, and then we just do calculations on them to build out all that scoring and models here. So it looks like a lot of code, but a lot of it is just the building those reports here. And then we have the explore inference task. This is the one that we saw before. If you were at the beginning, we can also expand this into a bigger report here. So this we pass in this case 12, but you could overwrite to be different examples here. We have 12 here. We can see that the accuracy was 92%. It only got one wrong for that 12 that we passed in. And then we'll actually deploy our model. We can play around with any other text and see how it performs. But we can look and see. Let's actually see which one was wrong too. So this one is correct. It says, I was feeling really troubled and down over what my dad said. And then you can see that sadness, and that's very like high confident that it's probably sadness. It thinks maybe a little bit of it could be fear, which also makes sense because it kind of, they are very close to each other and like what it sounds like probably. And then you can see there's attention that's computed what the model looks for its prediction, and the darker is equal more attention on it. So this troubled is the most, and then I. So it's kind of thinking probably like I am troubled. It's probably going to be a fear type of thing. And then what's one that was incorrect? I'm actually curious. Here's the wrong answer one. So it says, I feel a strange gratitude for the, oh yeah. So for occupation, and it's a much longer one. And then it's true as surprise is what it's labeled as, but it's predicted as anger. But you can also see it's a lot less confident on these ones. And my report is broken here with these longer ones. I need to fix that, so it wraps it. But you can see strange is what it's looking at, has hated in there. But also we have words like gratitude and hated. So we probably need more variations of things that are, I think it's called negation, where you have like these words that sound bad that can actually end up being a good thing as well. And it's probably, again, just a limitation on the examples. So we only did 4,000 of them. There's probably just not a ton of them. And we only did 3 epochs. So again, like most machine learning models, you need good data sets in to get the results that you're looking for. So most likely that's one of the things here. So building this out, again, it's going to be a lot of HTML in here that I should probably try to break out into another folder. I already did with some of it. There's like a reports helper folder. But this reads in the fine-tuned model. It's going to read in the 12 samples that we're going to pass in, initializes the model, kind of like we've seen before, sets it to CUDA. And then some of the interesting stuff here is, let me scroll down a little bit. Again, it looks different in Colab. Initialize our report. We tokenize, do forward pass with the attention. So here's some of the attention stuff. So we look at the logits, which is usually like the last layer before your actual prediction head, and you're pulling in the basically like what it thinks are the probabilities. That's how we are able to pull out this information. Like basically, you can imagine that there's 6 nodes there, and or it can be another dense layer, but they're going to go to these 6 nodes, and you get this kind of percentage thing before it actually lights one up. So we can calculate kind of this confidence score that you want to call it, or something like that. And then we are getting the attention part from the tokens. So we initialize our last layer attention. We get it, the number of heads, the sequence length, and then we average the average across them and take the the score there basically, and then we put it in the mask there, or put on the mask for into the tokens. Except for these ones. So if it has some of the special tokens in the outputs, we don't want to classify those ones, just basically these specific words. And then we do token importance via gradient attribution. So you rerun the gradients enabled on embeddings. So you're basically getting each word here, or token, I guess, because I think it's actually broken out per token. If you have more of the longer words, it should be broken in. Most of these look like full words. I believe I did it for tokens though. Yeah. And this is going to get the token importance, not the attention layer. And then highlight which one it thinks is, again, more important to look at the score. So if you looked at some of the like original attention paper, and you can kind of see how you pull out these things, like those different layers, like your key, value, and query layer, and or sorry, key and value for the query that was coming in, and then you can kind of see the attention amount on those things. And what I was going to mention is that, so we're just doing this kind of manually here. There are other tools, like there's even one for BERT models called like BERT Viz that can, I think, help you do this probably a little bit cleaner even than the way we're doing it, or it's just behind the scenes, so there's an abstraction on it, and you might be able to have better visualizations. I haven't looked at it in a long time. So there's other tools like SHAP values, I think, also you can use for transformers and get kind of the attention layer for the tokens. And again, this is all HTML, making those cool reports. If we scroll down, we have the pipeline where we're tying it all together. Again, there's some HTML here because I enable a report on the entire pipeline. So as it's running, you can kind of see some stuff here as well. But this really isn't that much code. All we're really doing is defining or calling those tasks that we created, but inside of another task. So here we have task report is equal to true again. And this one's on our CPU task, and then it's calling those other tasks that we created. So we call that get data one, we call the training one, and then we pass in, basically we get that fine-tuned model right in the data set, and we call it, and then we pass in the variables that we defined here. So fine-tuned model goes into our next one, which is that evaluate. We're passing the fine-tuned model that got returned out of that, and then we have our all of our calls kind of tied together here, and that creates our pipeline. So people were able to run this. Did you run it? Did you get any cool results? Let me open up my my link again. To go to my BERT one. Oh, cool. It looks like other people actually got completed pipelines as well. Any questions? If not, the chat's pretty quiet today, which is fine. But I do see a lot of people sticking around too, which is cool. So I'll keep going. I show how to run the pipeline again. I walk through the code. I do show how to run the pipeline again after the code walkthrough. The this talks a little bit more about how the attention visualization works, and then we're going to serve the model. So again, going with like how we did it before, you can just run this first. Since we're in the same project, actually, we already have our model served, and this should work. You probably don't have to rerun this. If you want to, you can. But if you go to your UI here, you'll actually see this apps tab. You can click into it, and you can actually see we have two things here. One is Emotion Classifier UI. One is Emotion Classifier API. So this first one that I hit deploy on, again, you don't actually have to run this because it's already going to be deployed for you here, is going to deploy our model to a fast API endpoint. And a cool thing is this is going to get the latest version. So actually, since I hit deploy, this is going to look at these runs inside this pipeline task. And again, you can see these all versions from different teammates or people in the workshop in this case. So it's actually going to look at this latest one and pull in the model. So hopefully the model is good. I don't know if they change hyperparameters when they're running it. No, it looks great here. So it's going to pull in the latest one by default, but I also have it so you can pass in a specific run ID. So if you are doing like hyperparameter tuning and you know that one of your previous runs is better after looking at your reports, you could actually go in and go like, so this one was better and we want to get this specific one. You can copy this hash ID, which is like a name for our run here, our specific version of the run. And then you could paste it here, and then it would pull in the output from that version of the run, not the one that was the latest. So really useful if you're doing like, training models, doing hyperparameter tuning like a lot of people are, and then you want to be able to go pull specific artifacts from specific runs. You can do all that with hashes. And everything we're doing in the UI here, you can do through like the API programmatically, like navigating different versions, looking at outputs and stuff from these different tasks. You can pull in from the Flyte API or remote API. So this deployed, and you look at the code here. This is a pretty simple, just fast API server. One thing to note that's pretty cool, that is a Flyte specific feature here, because we're actually deploying it kind of in this Flyte UI. We also have Flyte or Union managing the resources. So inside here, just like for our tasks, you can say how many CPUs, memory, GPUs, etc. that you need for this app to run or model to be hosted in. And you can also define scaling. In this case, it's going to scale down to 0 by default, but then up to 1 when you start requesting on it. You could have scale down to 1, and then you could have it scale up to a whole bunch of different replicas if you wanted to. As more users are like visiting your site or querying your model, it can scale up to kind of handle that. And you can add in this scale down metric. So in this case, the scale down after, I forget how many minutes that is, but this is seconds. So it could be, you could say after 5 minutes of nobody pinging this, or 30 minutes or hours, scale down to 0. So I'm not like consuming those resources, right? You can also set authentication to false. By default, it's true. So you'd have to authenticate in to get access to the model or app. But today we have it set to false. So you should actually be able to do this even if you didn't sign up for an account yet, or access it when it's deployed. I mean, not just run this. And it's going to look at this task name, that BERT emotion CPI, BERT emotion CPU pipeline. And that's where it's going to try to pull in that latest output here. But again, we could pass in that specific model path if we wanted to, and then pull in a different artifact from it. And then everything else is a kind of pretty basic fast API kind of thing here that you can go look at if you want. It's not too much code. And now that our model is hosted, we actually want to get our model UI. So we can go here. Again, we want this API one, not the UI one. The UI one is going to be this Gradio app. But first, let's just get this API. I can actually click in, and I'm going to copy this URL here. So now this is our model is hosted here. I'm going to paste this in, and we can do a curl to check. Make sure that you leave this /predict. That's actually the endpoint that's going to return the predictions for us. So I'm going to run this, and we can see that we actually got a prediction back from this text that we sent in as "I am so happy today." And we can see that confidence score is very high, that it is joy. And it's going to give us some other data, basically all the stuff that got logged in the pipeline, like scores for those other ones, the probabilities for the other ones. And then for the Gradio app, you could run this. Again, you don't have to run it because it's already deployed. Python app.gradio. This is going to now give us a UI for that endpoint. And you can explore the Gradio app here. Nothing really special in here either. It does the same thing. It's a Flyte app, so you can give it specific resources that you need, authentication, etc. The scaling down, that's all done in here as well. And then otherwise, this is just a Gradio app that gives us the UI that you're going to see here. So actually, I'll paste this in. Even if you didn't sign up, you should be able to play around with this during the workshop if you want to. If we all use it at once, maybe it'll go slow. I'm not 100% sure because we don't have that auto scaling that I was talking about. But we can run this. I'm so happy. Right now, everything is going great. And you can see, get the score. And again, how fast this is without a lot of, actually no tuning. and we're calculating all these results and we're running it in eager mode instead of using flash attention. So imagine if you do any other type of like optimization on this model, how fast this could run for classification in your like pipeline on real data. It can go really, really fast. So we could try out, let's try something a little more complicated. Anyone have any text they want to try? Again, I shared the link, so you should probably be able to try this as well. What's something that's like has some of the negation that might be able to trick it a little bit, like where we have two words that are like negative and positive. Like, what if I say I hate that I love this so much? I guess that's really complex actually too, because like I'm usually when people say this, they like really like the thing, and they're like, I guess somewhat disappointed that they like the thing because maybe they didn't like the person who made it or something like that. And let's see what it says. So, I mean, it's kind of how I would read it. Actually, I would imagine without hearing tone, it's hard. But if people say this in my life, I feel like they're actually, they actually like the thing they're talking about, but they're kind of sad that I don't know, they're supporting something they don't like, or it's made by somebody or something like that, or that it's something they haven't tried in a long time or like ever, and they're putting off, and then they tried it. So a little bit of sadness, but overall, it's predicting love as the highest one. What's some other fun use cases to try? Also, what do people think? I know chat was a little quiet today, but I still saw quite a few people here, at least watching it, and I did see some people running the workshop as well. So I'll stick around. I can keep trying some more examples, but we got to the end really of the content here, and like I mentioned, you can also go run this all on the open source too if you want to set it up. You could also run it just locally without setting up the dev box with that local -- local flag that I had mentioned before as well. If you want to train your model without kind of getting the UI reproducibility of containers, you could take this code and have Claude rip out the Flyte part if you don't want it at all. But what do people think? Anything interesting? What was the most interesting thing that stuck out to you? Oh, also, this is kind of funny. Most attended words. So it's really latching onto this exclamation mark for some reason. And maybe that would be something too that like, well, I don't know. Maybe you want to have that in there. In that case, oh wow, that's interesting. Look how much like love, the percentage of love went up. So when we add this exclamation mark, it's looking at that and it brings it down quite a bit for love. Like when you say it with this, maybe it's adding a little bit more negative emotion. I wonder if we add a whole bunch. Oh, it went up. If we add a question mark after, love went down quite a bit and sadness went up, which I guess makes sense. Like it sounds way more confusing. So it's really fun to kind of debug about like, how your transformer in this case is using the attention layers to reason about this. So pretty interesting. Oh, so someone said, I am happy, but I'm really not sad. I think that's what you said, right? I am happy, but I'm really not sad. It did a really good job there. I'm happy, but I'm really not sad. You'd think it might just pick up on the, like if you're using more classic sentiment models like that are built into like NLTK, which is was a really popular natural language processing library for Python. Like I'd used it before the transformer boom, before BERT models were out. That you could trick really easily just by adding in like another word like sad, for example. It would really, really bring it down. But you can see like the transformer model in this case is actually doing a way better job of oh yeah, we do have the heat map here. So it's like tracking. Oh yeah, see, it actually put a lot of focus on but for this attention part. So it's probably saying I am happy, and then a lot of attention focused to but. It says, but I'm really not sad. So sometimes it'll Sometimes it doesn't work perfect. Again, we had a pretty limited data set here and trained it only in a few epochs. So it's not going to be perfect, but you can see that the attention part and transformer is actually probably doing quite a bit better than some of those other classical natural language processing models. And Carl said, thank you. It was really great. Awesome. Yeah. Thank you for coming and thank you for letting me know and talking in the chat. It's always way more fun when somebody is talking a little bit in the chat. Any other questions or comments or any text people want me to try on this? One thing when I've done this workshop before is I would bring in movie reviews because I was doing it on like the movie review data set, which again is like the binary classification, which I don't think is quite as fun. I think this is a little bit more fun, but we could paste one in and see what how it does classify in a movie review. Let's see. Is Toy Story 5 out yet? No. It's opening this week, I guess. I didn't know it was coming out this week already. Let's look at what's something that's going to have some mixed reviews. Somebody said, thank you. It was new to me. I will try it later. Awesome. Yeah. Hopefully, if it was very new to you, hopefully it was a fun introduction to whatever was new to you, like whether that's like all the models, Hugging Face, fine tuning. In this case, again, for fine tuning, we just updated all the weights here because it's a small enough model where we don't need anything like LoRa, QLoRa. I did a workshop a couple weeks ago. So if you're looking to fine tune a actual large language model on some sort of task and you want to use something like LoRa or QLoRa, that makes it way easier to do on like you can load in a smaller matrix and update that and get really good results on a GPU. Check out my last workshop. I was going to pull in. Let's see, this is a negative review. Oh, it's a whole thing here. I actually don't know how it does on like a glob of text. Let's try it since I'm already here. This might be really weird because I think all the samples are pretty small. So in our training data set. I don't think it worked very good for this one. We probably need I think the movie data set, for example, is actually like large paragraphs and will work for this. I wanted like, usually there's short ones I thought that I could pull from Rotten Tomatoes. Anyway, I just thought it'd be fun to throw in if people don't have other things they want to try. Okay, here we go. We get, and you could do like a prediction of 1 to 5 stars, I guess. It'd be interesting versus doing just binary classification. Pretty joyful. A lot of attention to this thing about like what entity they're talking about. Yeah, it's interesting, like kind of debugging where the attention layer is. Same with if you've ever done like observability stuff on computer vision, it's always interesting to see like what are the parts that make it tag that animal as a specific thing. Like if you're looking at cats and you think the cat classifier is going to look at like the ears the most or something like that. And when you actually look at it, a lot of times, from my experience anyway, it's like the mouth and other parts of the body that I would think that it would be using to make the classification part. It's always interesting seeing like what's going on inside of models. Cool. Any other questions? I know we're a little bit over the hour. I gotta go jump and do some other stuff here shortly, but I do want to leave it open again for a few minutes if there's any other questions that people have for me. If not, I'll wrap up the stream. But I want to say thank you again for everyone for being here, talking in the chat. And if you want to, you can join the Slack group and check out everything else that we're doing. I think we do a lot of cool stuff, not only in the AI tooling space, but also just like event-wise and discussion. There's an AI news channel that's really fun to share stuff in as well. So join that out if you're interested. And then also if you want to stay connected with me, you can find me on LinkedIn is probably where I'm most active as well. So feel free to message me there too. But yeah, any other questions or comments? Was there anything you thought was cool? What's the most interesting thing? Or do you have like an application in mind for something like this now? Can you see how this would be useful to use like in production versus just using a large language model? Like you fine tune this on your own data set, you get to own that model, own where it runs. Data never leaves your on-prem if that's a concern, like a lot of times it is for many organizations. And it's really fast and cheap to run. So like if you're doing this on every message sent on something, probably wouldn't want to be doing that in like a ChatGPT or Claude type of way. You'd probably want to have this hosted model that's going to be incredibly cheap for you to manage. I still see people hanging out. They haven't been dropping off yet. So I'm going to wait and see if there's any questions. But otherwise, I'm going to, I guess, end the stream. If there are no questions, let me know. It was great. Thank you, everyone. It was great. Let's see. Should be Joy. Oh, I think our model scaled down because we hadn't used it in 5 minutes. So it's going to scale it back up. That's why it's taking a while here. All right. Once we get this returned, then I'll wrap up the stream. So very high Joy. All right. Thank you, everyone. If you do have any questions, find me in Slack, find me on LinkedIn. Hopefully this is really interesting for you or fun. I had fun doing it. So I'll talk to some of you later. Thank you.